US Physics Olympiad year 2013, F equal MA, first round. Problem number 4. The sign shown below consists of two uniform legs attached by a frictionless hinge. The coefficient of friction between the ground and the legs is μ. Which of the following gives the maximum value of theta such that the sign will not collapse? Solution. First, let's draw the picture with forces. I just show forces on left leg. For right leg we have symmetrical forces. So on left leg we have mg, which is applied to the middle of the leg going down. We have force P, which is applied from the right leg horizontally. We have normal force, which is applied on bottom of the left leg. And we have force of friction F, which is applied to the left leg to the right. In case of static equilibrium, we have to write equations for horizontal, vertical equilibrium and for rotational equilibrium. Let's do it for horizontal equilibrium. For horizontal equilibrium to the left leg, we have to equalize force P to force F, force of friction. For vertical, we have to equalize normal force and mg. And for rotational equilibrium, we have to choose the point of rotation. In our case, that will be best point, this one where we apply force N and force F. In that case, we don't have to count torques from these two forces because they are zero. And now we have clockwise force mg and torque from this force equalized by counterclockwise torque from force P. Let's write this equation. So for rotational equilibrium we have this equation. That's a rotational equilibrium where we use that P equal F, force of friction. Now we can express force of friction from this equation. So from here we can find what is force of friction. That's this one. But we know that force of friction cannot exceed μ multiplied by normal force, which in our case equal mg. It will be critical for our case. If force of friction equal μ mg, we can put it here and find that critical angle will be when tangent theta over 2 equal 2 μ, which is answer E. Problems 5 and 6. The following information applies to questions 5 and 6. A student steps onto a stationary elevator and stands on a bathroom scale. The elevator then travels from the top of the building to the bottom. The student records the reading on the scale as a function of time. Question: at what times does the student have maximum downward velocity? Question 6. How tall is the building? Solution. As we can see from the picture, from 0 to 2 seconds elevator is not moving because reading of scales is the same as student's weight. But between 2 and 4 seconds reading is just 60 kilograms. It means that elevator going down with a constant acceleration. So velocity is increasing. And when it reaches 4 seconds, it start to move with a constant velocity, because here we have reading of scales is the same as weight of student. So we have maximum velocity between 4 and 22 seconds. And after that, the reading is going up. It means that elevator going with deceleration with the same amount as it was acceleration. And it reached the 0 in 24 seconds. After that, it's not moving. So it means that answer for question A is between 4 and 22 seconds, which is answer C. Question number 6. How tall is the building? Now let's convert our sentences to formulas here. So first we can find what is the equation for student's motion between 2 and 4 seconds. That will be MA equal mg minus normal force. In our case, mg equal 800 newtons, normal force is 600 newtons, and mass is 80 kilograms. It means that acceleration equal 2.5 meters per second square. Now we can find what is the distance covered by elevator between 2 and 4 seconds. That will be 1/2 AT1 square, which is 5 meters. Now let's count what is the speed after 4 seconds. That will be AT1, which is 5 meters per second. Now let's count what is the distance covered between 4 and 22 seconds. That will be V multiplied by T2, which is 18 seconds, and total is 90 meters. And now we can count what is distance covered between 22 and 24 seconds. That will be symmetrical deceleration, same as acceleration between 2 and 4. So it means that distance here will be 5 meters. It means that the total height of this building equal 5 plus 90 plus 5, which is 100 meters. So that's answer C.